Hey everyone, welcome to another devlog. It's been a bit since the last one, where we actually did a release, got some really good feedback, found some issues that I will add to my to-do list, including some laggy ones related to collisions, I think. Something I'm going to be looking at. But yeah, I thought I'd give an update on how we're progressing, because a decent amount has happened since the last one. So let's just jump right into it. So first off, most obvious, I think, when you first boot up the game is, well, we'll get to the multiple projectiles in a sec. You now have slots, and in fact, you can equip your skill to different slots. So I can disconnect it from my left click, and now it will fire when I press E or when I press R, which is what I'm pressing right now. And you'll see that I can now fire the skill. That's pretty cool. So yeah, this way will allow players to control. Obviously, these are hard coded really right now to QEWR space. Eventually, we'll have an options menu for that, but pretty happy now. It does mean we'll start including more active skills when we get to it. The next big thing is we fixed a bug with passive tree. I think I probably mentioned in one of the previous devlogs that if you took this path here, because of the way I had coded it, you weren't able to take this node because it considered this node here to be a prerequisite. Well, I've done away with dependencies and prerequisites. Everything just has a list of neighbors, which actually by itself didn't really solve the problem, but it was a necessary step to just sort of clean up the code and make it clearer that there isn't really a directionality to this. The only thing that matters is that every node has a connection to the core node, which is a bit of fancy code I'll go through in a bit later if you're interested in it. But basically, a node now, when I try to remove it, so if I right click this node, it's checking its neighbors and saying, do you have a path to the core? This node here does not have a path to the core, so therefore I cannot remove this node. But it will let me remove this node, or this node, and then this node, and then this node. So the skill tree is now working great. So that's the second big thing. The third thing, and this is sort of in progress, we're still not quite there yet, is support skills. So if you're, I probably mentioned it in the game, but the idea is this is not going to be the entire passive tree. As players level up, they'll be able to pick support skills, and this is where they'll go. And you get these little slots, so you can put it in, and it will expand the passive tree. Now, right now, this is meant to represent multiple projectiles. It isn't actually doing anything yet. I had to code multiple projectiles into the game to work before I can make this node actually increase that, which is what you saw before. But it does draw the node. I can set values on these nodes, and it does properly draw the lines and highlight those lines as you select through it, which is really nice for UI. Another really cool thing is it will actually account for the position, or I should say the rotation, of the node. So if I was to take this node over here instead, it will draw it out to the side. Now, I know the angle isn't quite matched. Don't worry about it. This one here is hand drawn. It's not correct. This one is actually correct at 72 degrees. It's what I want it to be. But you'll see that it rotates it. So as we get more of these nodes around, you'll be able to expand the support tree, the skill tree in a bunch of different directions. The last thing is what you saw at the start, which is that I have multiple projectiles now. There was a bit of thought going into exactly how to code these. There's more than one way you could spread the projectiles. The way I've done it for this iteration is they spread at 5-degree increments, but you could also give yourself a cone of fire. I decided to go with the degree increments change, I think, degree increments calculation. I think it works out to be a bit better. Obviously, there's some little fancy things to fix, like if I just shoot all into one, they all get absorbed by one, when really it should only absorb a few necessary ones, so that's something for me to look at later. But right now, everything in terms of the actual projectile shooting is working correctly. And what is cool is that if I change how many projectiles I have to an even number, it will still work and still give me that 5 degrees calculation. It'll still give me that 5 degrees spacing. So that took a bit of effort to figure out, but pretty happy with how I've done it. For anyone interested in the coding, two things I want to call out. If you're interested in the way I'm calculating the angles, I'm not an expert game dev. This is just when I was sitting here thinking about how to do it, how I decided to do it. But the short version is we get the initial target, initial angle towards wherever they've clicked. We have an angle offset, which we track. And we also have a spacing number, which we're starting at 5 degrees. We can change that as you please. There probably will be passives for it. That offset is then applied. So it goes through two things. If there's an odd number, it creates an initial projectile on the actual click. So you'll always get a projectile where you click. And then for each child attack, it's going to do two things. If it's a positive number, it increments it first, but then each time it creates a projectile and attacks with it, it changes the offset. And first, if it's in positive, it will increase it, it will change it to negative. If it's negative, it will increase it and then change it to positive. And in this way, it'll scale to however many projectiles you have. If it's even, it's almost the same thing, except we don't draw a projectile at the starting position at the click, but we do generate a sort of starting offset, which is half of that spacing. So if you imagine I fire two projectiles, you would want the first one to be at 2.5 degrees and the second one to be at negative 2.5 degrees if you've got 5 degrees of spacing, because that's 5 degrees of spacing. So that is how that works. The other little bit of cool code is in the way it's removable. I don't know if this line here is necessary anymore, so I'm going to try experimenting with getting rid of it. But the main flashy thing is this path to root. This took me about a day of thinking about it and trying to figure out a good way to do this. So basically the way it works is when you try to remove a node, it'll say, for each passive in my neighbors, do they have a path to root? And it will pass in an array of itself. This array of nodes to ignore, whenever a node gets asked, do you have a path to root? It'll add itself to this array. So basically, if you try to imagine, right, I'm trying to remove a node, I'm trying to remove this node here. It's saying, ignore me. Hey neighbor, do you have a path to root? Hey neighbor, do you have a path to root? And then this one says, okay, ignore me. Neighbor, do you have a path to root? And this one says, hey, ignore me. Do you have a path to root? And this one says, I am the root. And then that goes up the chain. And this one says, cool, this path is removable. However, this one isn't. Therefore, I'm not removable. And that's essentially what this function is doing. It only needs one to work. We haven't scaled testing, so there might be a bug here, but pretty proud of this. For how much time I spent thinking about the problem, it's really only like 10 lines of code, but still, I'm pretty happy with it. So yeah, thanks for watching. If you've got any questions, let me know.